Yes. So good morning, all of you. Am I audible? Can anyone please confirm?
Yes, sir.
Great. So we will just wait for 2 or 3 minutes so everyone can join the session. Then after we'll proceed for the a bit introduction about the digital electronics and we will differentiate the analog and digital. And then after we will move forward with the number system. So just take a patience. So we'll start within 2 or 3 minutes. Okay, fine. So I think almost the most of the students joined the session. So if I speak about the previous sessions, I think we took a glance look about the digital electronic syllabus and a bit idea about the teaching scheme. But within a week, definitely I will set you the exact teaching scheme. And this is our department level subject. So you don't have any mid-semester examination and final exam by the Marwad University. But we faculty from the DE side will took the department level examination. So before going ahead, let me, yeah. So first we'll be familiar about the what is analog and what is the digital system. So analog and digital system are used to transmit information. Suppose that you have a huge number of data, such as any video, in audio, like MP3 format or MP4 format, AVI format, any kind of the format. So audio or video is one kind of the information. So I think most of the people are surfing the internet. Then after you are watching the TV, so all are the resources coming from the information. So usually through electrical signals. So information you can transfer by wireless medium as well as the wired medium. Suppose that you are surfing the internet because of the network scheme. So this is the wireless scheme. Suppose that you are getting the internet because of the physical connection like LAN cable. So this is the wired connection. So in digital technology, translation of information is into binary. So in digital system, generally we are using the only two digit, that is 0 and 1. So generally I speak out the 0 as a low signal, 1 as a high signal. Sometimes you can also call it as a 0 as a off state and 1 as a on state. So the information is translated into electrical pulse of varying amplitude in analog technology. So ultimately you can able to convert any signal, like you can able to convert analog signal to the digital and digital into analog. So let me move forward with the terminology. What is the main difference between signal, waves and representation? So analog signal represent the physical measurement while digital signal are discrete. So only one main difference, key line difference between analog and digital is that analog nature is the analogy, while digital nature is the discrete. So generated by digital modulation. So if you want to generate any signal in the digital system, it is possible using the digital modulation. While in the analog system, it can be generated by the physical measurement. You need to perform the practical, then after you can able to generate the signal. Like generally, analog system is a sine wave type, like cosine signal, sine. So those are the examples of the wave in analog system. While in digital system, generally you are practical perform with the square wave. So square wave is something looking like this. Let me show you. I think next slide. So here example is given. You can see here above part is the analog system and below part is the digital system. So analog signal is something looking like sine or cosine. So if signal is starting from 0, so it's represented as a sine. And if signal is starting from 90-degree angle, then it's represented as a like cosine wave. So cosine and sine is the example of analog. Even more, if I give you the best example, suppose that you people are using the bike. So in the older system of the automobile sector, generally in the speedometer, there is a one scale. Suppose that if you are increasing the speed or decreasing the speed, so scale will move on the dial. Like starting speed is 40 kilometer per hour, then after 50 kilometer, 90 kilometer. So scale will respectively move on the dial. While in the digital system, the system it's something looking like the LED display, 7-segment display. So here one indication is like 6.25. So you can consider the bike example as well as the suppose that you are taking the reading of voltage, if you are taking the reading of the resistance, if you are taking the result of the what is the ampere of current, then this is the main key difference between the analog system and digital. So digital system is something looking like here. You can see x-axis and y-axis here. 1 is high, 0 is low. So 1 0 1 0 1 0 pattern is generally comes in the digital system. So this is the main key difference. If we classify, like I want to exactly differentiate between the digital electronics and analog electronics, sometimes they will ask you in 4 marks because this is a really important question. So we'll took one by one example. First, digital electronics deals with digital signal, which is discrete signal. So whenever anyone asks you what is the nature of the digital electronic signal, that is discrete signal. Must be remembered, digital electronics deals with digital signal, which is always discrete, while in analog electronics deals with analog signal, which is continuous signal. So you can see here, in the analog system, signal is completely continuous up to the infinite time. Suppose that if you are not stopping the signal, it will be continuous up to the infinite time. Most of the signal in nature of the discrete in nature. So in digital electronic signal nature is discrete, while in analog system nature of the signal is the analog. Third point, digital electronics the processing of discrete signal that are associated with the numbers. Now they are taking one example. The electronics is designed to process predefined values like 0 voltage and 3 voltage. Yeah. Now suppose that I am giving the value of the voltage. You have a two reading. One is the 0 volt and second is the 3 voltage. So I will associate 0 voltage as a 0 value and 3 voltage as a 1 value. You can also take the another example like 2 voltage is given there, 4 voltage is given there, 6 voltage or 8 voltage. So maximum voltage will be associated with the value 1 and minimum voltage is associated the value of 0. So using this voltage you can create the discrete graph, and that is digital electronic system. So binary codes being the most used example like in computer system. So generally whenever you are pressing the key in your keyboard, so keyboard is the ASCII value. So ASCII value will be converted in the hex or binary. So for suppose that ASCII is converted into hex, we can able to convert the hex into binary, and CPU will understand the binary value, and binary value will be transferred to the display. If I speak about the analog electronics, so analog electronics is the processing of continuous voltage and current that can have any values between two limits. So in the analog side, the value must be anything like 2.5, 3.5, 4, 6.55. Any kind of the value you can represent in the analog type. So signal of an audio output amplifier for your speakers, the amplifier of the microwave signal, radio transmitter, sender station, RF studio, anything, any electronic signal are transmitted by any kind of the medium. So most of we are using the analog system. Then after example is given here, digital electronics is almost exclusively used for the signal processing and transmitting. So what is the main use of digital electronics? The main two uses signal processing, and then after we are transmitting the signal. If I speak about the analog electronics, it can be used for signal processing as well as the transmission. But also we are using in many areas like computer vision, then after communication, then after machine learning. Too many use of the analog electronics. Now example is already few people are familiar with it. In digital electronics side, the signal is something looking like 0101 pattern. uh, 0 is represented here, then after signal is going to y, that means 1. Again signal is going to down, that means 00. Signal again rise up, that is 1. Again down, 011. This is digital signal. And analog signal example is here. You can see the on the x-axis we took the time, on y-axis we are taking the amplitude. So here one kind of the sine wave is given here. So this is the example of analog electronics. So this is highly important. So take a pen and paper, write down the question, difference between digital electronics and analog electronics, and differentiate it. Like for write down first 3 points from the digital side and 3 points from the analog side. Then after I will show you the second slide where 2 points are given here. One for the what is the use of any electronic system, and then after the second is the example. So start from here. Question is something like a difference between digital electronics and analog electronics, and write down this difference. So do quickly. All of you must need to write this because this is the highly important, and write down IMP question. So whenever you finish, just let me confirm so I can proceed for the second slide. So do it. Yes, sir. Sir. At what point do you have any question or query? Can you please tell me? Okay, fine. Yes, Ranjan. Do you have any question? I think you question mark in the chat. Yes, definitely I am going to say this, but it doesn't mean that you don't need to write. Because whenever you are practicing well, definitely it will help you to the gain knowledge. So right now, please write down. Afterwards, definitely I will say it. So don't practice like that. If I'm sharing or not sharing the material and you don't need to write. Because whenever you are writing, so writing will help you to remember the skills or remember the any content. Yeah, so all of you done? So I can move forward with the next slide. Can anyone confirm? Arju, Rahul, Prince, Jaideep Singh, Kishan, Ranjan. Okay, so all of you done or some people are writing? So should I need to wait or need to go ahead? Okay, so I think most of you done. Okay, this is the second slide. Only 2 points. One is the use and second is the example. Okay, someone said me wait 1 minute, so we are waiting for 1 minute. Be quick. Yes, someone asked me that, sir, you said in us something about the ESC end semester examination. So I said that you don't have any exam from the Marwadi University mid semester one or mid semester two or the final exam. We will take the department level exam 1 and department level exam 2. Then after some assessment like term work, IA component, CSE, so we'll uh, put out some like quizzes, assignment, active learning tasks, tutorials. But definitely I will say it within a week because still we are in the progress to build up the best teaching scheme for you. So just wait for a while. Then after within a next week lecture I will share with you. Okay, so let's move forward with the second slide. Yeah, write down this, and after we'll go for the various kind of the waveforms. So if you don't, just let me confirm. We can quickly finish and we'll move forward with the number system as well. So without completing, don't write the done, sir, because this is all for you. So if you're writing, definitely it will help you. It's for your enhancement. So be genuine. Yes, someone asked me that, sir, do we need to make a separate book for the D? Yes, you people need to, you can buy a 200 pages book, starting 100 pages for the theory session and remaining 100 pages is for the lab session. So if you are making such kind of the class note, definitely it will help you for the department level exam 1 and the department level exam 2. So you don't need to go any kind of the material or any like reference books, PPTs. So definitely class book will help you to cover up the all the sessions and to learn the each and every activity. So I think I was teaching for many years and students are making the best of the best class note, and definitely generally we are asking from the class notes. So if any topic is not covered and some topics are from the gate level, so that time I will tell you this is the hard topic. You don't need to write. You this is only for the gate topic or GRE topic. So class note definitely will help you. So I request everyone that prepare well class note. Yes. So I think we'll add the 5 marks for this book for your class note in the term one. So if you are writing everything in the class note, definitely I will give 5 out of 5. If your people are not practicing or writing, definitely you will get the respective like marks. So all of you done? Can we go ahead now? Yeah. So great. Okay. Then after what next topic is logic level, but logic level is not in our syllabus. This is the advanced topic. Yeah, now we'll see the different kind of the waveforms. So here in the above figure you are showing the sine wave. So sine wave is something like continuous signal, and this is the part of the analog electronics. In the below side there is a one mistake. Actually this is not sine, let me correct it. This is the square. Okay. So actually we are seeing the different kind of the waveform. First one. So first one is your sine wave. So you can see here starting from 0 and continuously going on the x-axis with respect to time. Then after there is a one waveform is the square wave. Square wave is something like the digital electronic system, like one is here, then after we can consider 0, then after one here. So this is the square type wave. Then after let me move forward with the just a minute. Yeah, then after rectangular waveform. So it's a group of the square waveform, but shape is something looking like rectangle. So you can see here, one shape is here. It's something looking like rectangle. Again, it's going to down. Again, it's rise up, down, rise up. But shape is rectangle. That's why we are called it a rectangle waveform. Then the Fourth type is the triangle waveform. So shape is something looking like a triangle is starting from zero, then after again rise. Like example like hill station. So you are rising, then after falling, then after again falling, rising, rising, falling, falling, rising, rising. So its shape is something looking like triangle. That's why we call it the triangular waveform. This is the fourth type. Then after sawtooth. So it's something looking like our tooth. So you can see here one angle is downing here, then after again creating rise, down, rise, rise, down. But shape is creating something like tooth, sawtooth. That's why we are called it the sawtooth waveform. Then after sixth one is pulse, like some rise up is immediately, quick rise. Then after again down and quick rise, again down, quick rise. So gap between rise and down is very small. So that is called the pulse. That's why we are called it a pulse waveform. So this is your pulse. That's all. So just draw these six kind of the waveforms. First is the sine, second is the square, then after rectangle, then after triangle, sawtooth and pulse. So first I will show you these two, type 1, type 2, then after we will move forward with 3, 4, 5 and 6. Yeah, someone asked me that, sorry, it is comes under analog or digital. So it's totally mix up. Suppose that first signal is sine, so it comes under analog. Second signal is square waveform, so it comes under the digital. In the next slide, I will tell you which signal will come in analog and which signal will come in digital part. So the above image is analog and down image is the digital. Someone asked me that, sir, what is the main difference between the square wave and rectangle wave? In the square wave, the rise situation and fall situation. So we are just calculating the time delay between rise and time delay between the fall. So in each square wave, the time delay is fixed. Like suppose that in the first positive half, time delay is 5. In the negative of time delay is 5. Again positive half, that is 5. In the negative of 5. So this is the square. While in the rectangle signal, time delay is not fixed. Sometimes it's 4, sometimes it's 2. And time delay is very less compared to square wave. So that is the main difference. In the square wave, time delay is a bit big, while in the rectangle, time delay is a bit less. Yes, it is possible using the oscillator. Someone asked me that, sir, is it possible that analog and digital we can show on the same side using the simulator like MATLAB or any oscilloscope? So you need to just connect the MATLAB with the oscilloscope, and you can run the both signal at the same time. So you can convert as well. Like if you want to convert the sine wave into square wave, it is possible. If you convert square wave into sine wave, it is also possible. So if you finished both these graphs, then just let me know. I will go with slide number 2. Okay, let me go ahead with the next waveforms. A rectangle waveform. Rectangle waveform is a part of the digital side, and triangle is the analog side. So rectangle generally comes in the digital. So you can represent the rectangle waveform with using of the 0 1 0 1 0 1 pattern. While the triangle waveform is not possible using the 0 1, but you can able to convert. So generally we are considering triangle waveform is analog side. So draw these two graphical arrangements. Then after we'll go for the third one. Yes, dear, the below said triangle is the analog type. But we can also able to convert triangle into 0 1 0 1. Like we can able to convert into digital one. So done all of you. Can I go ahead? Okay, we'll wait for 30 seconds for some people are writing. Yes, someone I think they asked me that, sir, what is the rectangular harmonic spectrum? So in the digital system, you are receiving the bit by using 0 1 0 1. So we can represent each bit using the graphical waveform, like it's some kind of the bar chart. Suppose that value is rising, you can represent as the 1. Suppose that value is down, you can represent as a 0. So we can able to create the spectrum like light rays contain the 7 colors. So if we encode the each color, so we can able to make the spectrum like one kind of the bar chart or any kind of the graph that is a spectrum. Like if I speak about any chemical liquid, so you can suppose that dividing the each component of the chemical, then we can make the each graph for the each component. So it's like one kind of the spectrum means we are representing the each value, where is 0, where is 1, where is 0, where is 1, and we are creating a bar graph, that is spectrum. Okay, now next. Sawtooth. So sawtooth is again one kind of the analog part, and pulse is one kind of the digital part. So this is the last one, fifth and sixth. So fifth is sawtooth waveform, and sixth is the pulse waveform. So draw quickly, and after I will teach you number system. It's very interesting part of the whole chapter. Yes, whenever you are getting the digital signal, that time, suppose that signal is high, so just make it 1. Suppose that signal is down, just make it 0. So you will get the pattern of 1 0 1 0 1 1 1, something like that. So you just need to represent the on the bar graph. Suppose that signal is 1, then just draw the bar. Suppose that signal is down, then draw the just 0 1 0. So we are just creating the pattern and representing on the bar graph. That is actually one kind of the spectrum. Yeah, why is 6 is high? Because we are just taking the example. I can took any kind of the example. They have another kind of the example. That's why. Yes, Ravi. Where did you see the duty cycle? I can't able to see the duty cycle. Can you tell me? Oh, in the pulse. Yeah. So yes, right. In the pulse wave downside, there is a 20% duty cycle, 50% duty cycle. Then after, just a minute, what is the impulse wave, right? 80% duty cycle. So this is based on the what is the maximum rise of the signal. Suppose that is starting from the 0 and going to 5. So each signal is a different kind of the magnitude. Suppose that you are creating one signal using the pulse waveform between 0 voltage to 5 voltage. So in this cycle, you can set the different kind of the value. Suppose that I want to transfer the signal to another location. So I will set the low ratio of the duty cycle. So it's one kind of a modulation. Suppose that if I raise the minimum, like mean average, like 50% duty cycle. So again, I will rise up like 0 to 5. So I will again set the modulation range. Then after again, I will increasing the 80%. So I will again enhance the modulation range. So it's depend on the transmission, which kind of the transmission medium is available. It is wired transmission, wireless transmission. Based on that, we are setting the duty cycle. So now done, all of you. Okay. Still some people are writing, so we'll wait for a while. Okay, now go ahead. So, which are the components of the digital electronics? So, it's one kind of the summary. Like, actually, there are four kind of the components. First is the component for the adding. Then after second is the components for routing. Then after the components for remembering, like one kind of the memory. And after sequential circuits. So, these four are the main basic components of the digital electronics. So, this is one kind of the conclusion of our whole subject. Suppose that if I speak about the components of adding, so in the third or fourth chapter, you people are studying the adders, subtractors. So these all are the components for the adding. So half adder is there, then after full adder is there, multi-bit adder, then after the multi-bit subtractor. So that is called the components of the adding. Suppose that I think you people are familiar about the logic gates. So logic gates is a one input like NOT gate. Sometimes it is a two input like AND gate and NOT gate. So just we need to mix up or we want to add the input A and input B. So using the adder it is possible. Suppose that if you want to subtract input A and B, so using the subtractor it is possible. So main component is the component for adding. And second type is the components of routing. So in the previous session I give you the example of the modem. Suppose that any service provider connection is coming, like LAN connection is at your home, then after you are routing in the multiple connections. Suppose that your PC1, then after laptop 2, PC3. So using one LAN connection you are getting the multiple output. So that is called the routing. Like multiplexer and demultiplexer is the best example for the routing. So you can see here one multiplexer is given here. Multiple connection is coming, but you are going to take only one output. If I speak about the demultiplexer, only one input is coming, and we are getting the multiple output like LAN connection 1, 2, 3, 4. So actually, we are getting only one connection from the service provider, but we are doing the multiple connection. So that is called the multi demultiplexer. Then after third type is the component for remembering. So actually when the memory comes in the picture, that time there is only one bit of memory. So one bit of memory was designed using the various kind of the latch and flip flop. So this is the part of the sequential circuit like SR latch is there, D latch is there, T latch is there, D flip flop, SR flip flop, JK flip flop. So we'll get the detailed idea about the flip flops in chapter number 5 and 6. And then after fourth topic is the sequential circuit like counter is there. Suppose that if you want to count in the process how many of the Pepsis are built for the day. So counter is able to count the total number of wishes. And after register is the part of memory and almost memory like RAM, ROM. So those are all for the main component of the circuit. So just take a glance look. Then after I will go in the number system. Just study it. Okay, I'm going to again first slide. And after I will, sorry, this one. And after we will understand the routings. I think someone have a question. What is the routing? So first read this. Then after we'll again go to the routing. If you want to write, then fine. If you don't want to write this, because this is like summary. Because we will cover the all topics in the detail in chapter number 5, chapter number 4, 5, and 6. Okay, now can I go for the routing? Can anyone confirm, please? Yes, now routing. Someone said me, sir, what is the routing? So routing in the simple language. Suppose that in the input side you have multiple input, but you just need the one output. So this is routing. In the opposite side, suppose that you have only one input, but you want to get the multiple output. So we are just converting multiple input to the single output, or we are converting single input into multiple output. That is called the routing. Simple. So routing has a two concept. One is the multiplexer and second is the demultiplexer. So multiplexer is doing multiple input, means they are getting the multiple input and we are getting the one output. That is multiplexer. Means we are multiplying the each data and in the output side we are getting only one single data. In the demultiplexer, we are only getting one input, like we have only single data, but we want to get the multiple data. So that is called the demultiplexer. Someone said me, sir, which kind of the input and output is there? Generally, there are too many kind of the input output. Suppose that if you are using the modem, so your LAN connection, so it's input, and you are getting the multiple output with a different kind of the LANs. So it's physical in reality. But in the DE concept, we will generally entertain with the binary numbers. So we are getting input as a binary, we are getting output as a binary. And in the gate side, if I show you some example, octal is there, then after decimal is there, hexa is there. But main in our syllabus, we are just entertaining with the binary number. So your input will be binary and output will be binary. Okay, now we are going for the third slide. That is remembering. Remembering is one kind of the memory purpose, like one bit memory. So using latch and flip flop, you can store the 1 byte, sorry, 1 bit of data. Actually, now you have a main question, sir. What we are using in the latch and flip-flop, which kind of the devices? We are just using the logic gates. That's what NAND gate and NOR gate. Simple. So you can able to see here the symbol of the NAND gate is given here. Or sometimes we are using the NOR. So using NAND and NOR, we are building the flip-flop and latches. Very simple. Don't tell to others. It's between you and us. Okay, now next fourth one is like last counter register memory. So register in memory is part of the memory. Memory is like PROM, RAM, EPROM, double EPROM, any kind of memory. Register is also helping us to enhance the range of the memory because latch and flip flop is generally only used for the 1 bit of data storage purpose, while register is for the byte. Like 8 bit is there, so using register you can get the 1 byte of the data storage, and counter is for the counting purpose. And now your questions are using which kind of the instruments or devices we can build up the counter register. Very simple. Using the latch and flip flop, you can design the counter and register. Okay, 1 minute of previous set. Fine. Okay, again, let me go to the this one, but be quick. Okay, now I think all the questions are done. Anyone have a question? Zero. Hmm? Components for adding, and after components for routing, components for remembering, and lastly sequential circuits, counter register in memory. Now this is the last logic gates. So you people are familiar with OR logic is there, AND logic is there, NOT logic is there. Then after NAND, NOT, exclusive OR. So various kind of the logic gates is available. Here I am just demonstrating of the overview. In gate is something looking like OR gate is there, NOT gate is there, and they have a truth table. Like in NAND gate, if two inputs are multiplied, 0 multiply 0, that is output is 0. 0 multiply with the 1, that is 0. 1 multiply with the 0, that is 0. So end operation is something looking like the multiplication, ગુણાકાર જેવું જ છે. But in the last one, both are the 1, 1 multiply 1, that is 1. If I speak about the OR gate, so OR is something like the addition type of, like 0 plus 0 is 0. So we are getting 0 as the output. 0 plus 1, that is 1. 1 plus 0 is 1. Now someone have a question, sir, 1 plus 1 equal to 2. But in the binary form, in the logic section, 1 plus 1 will become the 1. So in the OR gate, just remember, when both input are 0, that means output is 0. In the remaining 0, 1, 1, 0 or 1, 1, you are getting the 1 output. And all of you familiar with the NOT gate. NOT gate is for the inverting purpose. NOT gate will help us to convert the or switch the bit, like 0 will become 1, 1 will become 0. So if you are starting 1, you will get the off. If you are doing the off, you are getting the 1. So 0 will become 1 and 1 become 0. So it's right now 11:26. So just take a 3 or 5 minutes bio break. You don't need to leave the session. If you want to go for the bio break, then you can utilize this 3 to 4 minutes. Then after we'll start by the 11:30. But don't leave the session. After that, we'll start with the number system. Okay, students, now we are starting the important topic of our digital electronics, that is number system. So there are 4 number system in the arithmetic section in the digital electronics part. So first one is the decimal number system, and after second is the binary number system, third is the octal number system, and fourth is the hexadecimal number system. So must be remembered, basic 4 number system is available in the DE concept: decimal, binary, octal, hexadecimal. So decimal is a base of, let me write here, is base of 10. Then binary is base of 2. So what is the base of 2? In the binary system, only 2 digit. Sometimes we are using 0, either we are using 1. That means base 2. In the octal number system, base is 8. Means we are taking the number from 0 to 7. So 1 to 7 total 7 digits and 0 included, that means 8. In the decimal number system, we are taking 10 digits, means 0 to 9. 1 to 9 is 9 and we are adding 0, that means total 10 digit. That's why base is 10. In the hexadecimal system, base is 16. So in the hexadecimal system, we are using total 15, total 16 numbers starting from 0 to 15. So you people already know that 0 to 9, that is 10. Then after remaining 10, 11, 12, 13, 14, and 15. So actually we are not taking the digits here, 11, 12, 13, 14, something like that. We are giving the alphabets number like 10 equal to A, 11 equal to B, 12 equal to C, 13 equal to D, 14 equal to E, and 15 equal to F. So hexadecimal is the total mixture of the numericals as well as the alphabets. So just write down number system. In total 4 number system is available. Actually too many type of the number system, ASCII system, then after the BCD number system, gray code, XS3 code, but basically 4 number system is mandatory. Using this number system we can derive the remaining number system. So just write down this 4 title of it, the number system. Yes, in the hexadecimal ranjan we are using also alphabets. So firstly, we are taking the new numericals like 0 to 9 after 10. So we are not actually saying 10. We are saying it A. Then after 11, we are saying it B, C, D, E, and F. So 15 is represented as a F up to F.
What happened?
Yes, please. Anyone have a question? It's by mistake. Okay, fine. Okay, can we go ahead? I think it's very easy. Easy to remember decimal binary, octal hexa, decimal binary, octal hexa. Okay. So decimal number system contains the 10 digit. I already said starting from 0, it goes to 1, 2, 3, 4, 5, 6, 7, 8, 9. So last digit is 9, and starting is the 0. So just count total 10 digits are available. So that is why it's base 10, radix is 10. So here radix means total number of digits used in any system. So we are using the 10 digits 0 to 9. That means base is 10. Just take a glance look. Okay, now next number system. Actually, I will cover this part afterwards because when we'll start the converting, that time it will be better to understand. Right now, it's not mandatory. Just take a just overview. Binary. So in the binary number system, it is also a positional number system. So instead of 0 to 9, we are just using the two digits only, 0 and 1. So total digit is 2. So the base of the binary number system is 2. So whenever if they will ask you in one mark question, why binary number system base is 2, just stay by the your answer. So just tell that only two digits we are using, that is 0 and 1. That's why it's called the base 2 system. Now again, next number system. So here, the binary number system is known as the base 2. The value of positions are calculated taking the only 1 and zeros. So why is the base 2 for the binary number? Because we are using two digits. So I already said you. So if you want to write the question, just write it. One more question. This one is. Next one. So this is example of binary number system. So you will get only 1 and 0. So first number 11001010. This is the example of binary. All are the ones. This is all the example of binary. All are the zeros. So you can write any examples, like suppose that I'm writing so these are the example of binary. So just make the pattern of the one zeros. It will represent as a binary system. Now next, octal number system. So it's base 8 system. Why? Because we are using digits from 0 to 7. So total 8 digit is there. That's why it's known as the base 8 system. Radially converts to binary, so we can convert the vice versa, octal to binary, binary to octal. So just take a look. This is called the octal number system. Okay, now next one is the sorry, hexadecimal system. So hexadecimal is built up using the decimal numbers. So you have idea about the decimal. Decimal is starting from 0 to 9. Okay, while in the hexadecimal we are just taking the number from 0 to 9. Those are the numericals. After the 10, 11, 12, 13, 14, 15, we are taking the alpha bits. So 10 represent as a 11b, 12c, 13d, 14e, and 15f. So this is the 16 base system, because we are using 0 to 9 numericals, and then after letters are a, b, c, d, e, f. So total the 16 number is there. That's why it's called the uh, base 16 system. So group of 4 bits. So if I want to convert the decimal number system, so using 4 bit, I can represent the system. So I will let you know when we are converting the system. That time I will show you the another table. Right now, just draw this table, hexadecimal table, because it will help you. So whenever you see the 10, just definitely you need to say that that is A. Whenever you see the 14, just tell me that that is E. Whenever you see the 12, the same, it is C. So just draw the table, because it will definitely help you to convert the number system from vice versa. Yes, Ravi. Which point I need to repeat? Can you tell me at what point you are not getting? Yeah, you said me the groups of 4-bit. I think, let me show you. Now, Ravi asked us a very important question, sir. What is the 4-bit? So, actually, every number system is based on the binary. So, suppose that if I want to convert the hexadecimal number system into binary, so it's group of 4-bit. So, suppose that if I want to write 0 in the binary, so its pattern is something looking like 0, 0, 0, 0. So, why 0? Because let me convert this one. So, 2 raised to 0 is 0, 2 raised to 1 means 2. 2 raised to 2 means 4. Then after 2 raised to 3 means 8. Now here I am making division part. Okay. Suppose that if you want to write the 0, this 0 is hexadecimal, but I want to write in binary. So just calculate if I want to write 0, so all must be 0, 0, 0, 0, 0. Suppose that if I want to write the 1, then set 1 here. 2 raised to 0 means 1 here. So 0, 0, 0, 1. Why? Because 2 dash 2, 0 will become 1. So ultimately, x number 1 we can write by using 4-bit, that is 0, 0, 0, 1. Suppose that I want to write the x number 2 in binary pattern. So I need to set the 2 raised to 1. Why? 2 raised to 1 will become the 2. That's why I writing 1. Remaining bit will be reset 0, 0, 0. So 0, 0, 1, 0 will become 0. Suppose that if you want to write 10, okay, I will write 10 here. So 10 will become 8 plus 2. So I need to set 1 below 8 and I need to set 1 below 2. So I am writing 1 here and 1 here. Remaining bits will become 0. So 0, 0. So that is called the 4-bit grouping. Suppose that if I want to write the 15, let me clear all like 15. So 15 will become right something like 8, 4, 2, and 1. So just calculate how can we achieve the 15. So 8 plus 4 it will become 12. 12 plus 2 become 14. 14 plus 1 become 15. So we need to set each bit 1, 1, 1, 1. Why? Because we are using each and every digit. So using 8, using 4, using 2, using 1. If I total sum of 8 plus 4 plus 2 plus 1, so it will become 15. That's why we are using each digit. So I will write 1, 1, 1. Now clear? Actually, this topic will take up in the next slides because right now just this is the overview. So in the next slide, definitely I will resolve this issue and you will definitely get the concept. Am I audible? Some students are saying that, sir, we are not getting your voice. It is issue for all of you. Okay. I think you have internet issue, Ravi. Now, binary scale, then we don't need to go this slide. Now conversion, not here, decimal to binary, not this one. We're starting with the binary actually. So where is binary? Okay, now we will learn the conversion. This is very interesting topic. So we will first convert binary to decimal, then after we will convert binary to octal, and thirdly we will convert binary to hexadecimal. Total 4 number system. So we can convert the vice versa number system. So first point, binary to decimal. The easiest method for converting a binary number to a decimal equivalent to use the multiplication algorithm. So I will show you how can we use the multiplication algorithm, but must be remember for the MCQ. Sometimes they will ask you which algorithm we are using to convert binary to decimal. That is multiplication algorithm. So multiply the binary digit by increasing the power of 2 starting from right. So I will show you the example, then to find the decimal number equivalent in some of the total products. So let me show you one example. Suppose that this is one kind of the binary number 10101101. So first question, how to identify any number? It is decimal system, it is binary system, it is hexadecimal system, it is octal. So first must be check the base. So here base is 2. So whenever you are identify with the base, just say that this is binary. Suppose that if base is 8, then definitely say that this is the octal. Suppose that base is 10, so directly say that there is decimal. Suppose that base is 16, so directly say that this is the hexadecimal system. Right now, here base is 2, so all the numbers are the binary. Now we want to convert into decimal. We are moving forward from binary to decimal. Now first take the number. So I took the 1, then after 0, then after 1, then after 0, 1, 1, then after 0, 1. Now you need to write the power system. So starting from the right side, this side, then move forward with the left side. So you can call it the LSB. Anyone have idea what is the LSB and what is the MSB? કોઈને યાદ છે? Can anyone able to tell me what is the LSB and what is the MSB? Try it. બોલી પણ શકો છો, but people are used to write in the chat box. It's not good. So if you speak, it will help me. Said me Mahatam and Lagutam, nice. But what is the full form in English? Okay, fine. LSB means least significant bit and MSB means most significant bit. LSB means lower side. So this is the right hand side and we are considering as a lower bit. And this is the most significant bit, means maximum. So just you can call it as the right and left hand side. Sometimes in technical language we are saying the LSB and MSB, less significant bit and most significant bit. Now starting from this side, 1 is here. So below 1 you just need to write 2 raised to 0. Right? After you just need to increase the power. So 0 is here. So below the 0, 2 raised to 1. After 1 is here, so increase the power 2 raised to 2. After 1 is here, so increase the power 2 raised to 3. Increase the power 2 raised to 4. Then after 2 raised to 5, 2 raised to 6, 2 raised to 7. So below of the each binary number, you just need to increase the power starting from the right hand side and you need to go to the left hand side. So just see here, 2 raised to 0 is for 1, 2 raised to 1 for 0, 2 raised to 2, 2 raised to 3, 4, 5, 6 and 7. So I am just increasing the power of the base because our binary number system is containing the base 2 system. So write the base as a 2 in power in the increasing mode starting from 0, 1, 2, 3 up to the last digit. Suppose that this is my 8 digit, or so actually I am starting from 0 and it will become 8. That's why I write as a 2 raised to 7. So you need to start from the 0, goes up to the last digit. Now, 2 raised to 0, can anyone tell me what is the value 2 raised to 0 means? Not in chat box. If you really want to learn the conversation, just speak out. In the chat box, it must.
1.
Okay, 1.
1.
I'm writing 1. So 1 multiply 1. Now you need to multiply this number. 2 raised to 0 is 1. So 1 multiply 1. What is that? 1 multiply 1. Please speak.
1.
Okay. That's why I'm writing 1 here. Now second term from the 2 raised to 1. So 2 raised to 1 will become 2. So 2 multiply with 0. 2 and 0. If 2 and 0 will multiply? 0.
0.
But I am not writing 0 because 0 means 0. Okay. Then after we'll move forward with the 2 raised to 2. 2 raised to 2 means
4.
4. So 4 multiply with 1. That means
4.
that's why I write here 4. Then after 2 raised to 3. 2 raised to 3 means
8.
8. So 8 multiply with 1. That means 8. Now whenever you are saying the 0, that means there is a value 0. If 2 raised to 4 multiply with 0, actual answer is 0. That's why we are not writing 0. We are just writing the maximum values, expect zeros. Then after 2 raised to 5. So 2 raised to 5 means 2 multiply
32.
32.
32 multiply with the 1. That means 32. That's why I'm writing 32 here. Then after 2 raised to 6, no value because 2 raised to 6 is going to multiply with the 0. 2 raised to 6 કેટલા થાય actually? 64 થાય. But 64 multiply with 0. That means 0. Now last digit 2 raised to 7. 2 raised to 7 means 128. So 128 multiply with 1 means 128, right? Now you just need to total sum of. Now you have 1, 4, 8, 32, 128. Now use the calculator and tell me what is the final answer. Just add the numbers 128 plus 32 plus 8 plus 4 plus 1.
173.
173. So your final answer will be in decimal. Why? Because we are converting number from binary to decimal. So just you need to write the base value. So 170, don't write the only numerical value. 173 is correct answer, but just write the base here. So 173 with base 10. So that is your answer. Now let me take another example. Simple, very simple. 1 0 1 0. Fine. So we are starting from the right. This is your right and goes to the left. So below 0, we'll write 2 raised to 0. Then after we'll write 2 raised to 1. Afterwards we'll write the 2 raised to 2. Again we'll write 2 raised to 3. So 2 raised to 0 means 1. I am 1 away. So if 1 multiply with 0, so its answer is 0. Then after 2 raised to 1, 2 raised to 1 means, can anyone tell me 2 raised to 1?
2.
2. So 2 multiply with 1, that is 2. So I am writing 2 here. 2 raised to 2, that means 4. 4 multiply with 0, that is 0. Last digit, 2 raised to 3. Can anyone tell me 2 raised to 3 means?
8.
8.
8 multiply with 1. So I am writing 8 here. Now
8.
make a total sum. After the multiplication, do the sum. So 8 plus 0, 0 plus 2, 2 plus 0. Now tell me what is the answer?
10.
10. So,
10.
yes, so actual answer is 10. But you need to write the base. So 10 is the actual answer, but we are writing the base. Now clear? How can we able to convert binary to decimal? Everyone? Or I need to show another example?
Yes,
Okay.
yes, sir.
Okay, one more example. Fine. Suppose that binary number is
Hello, sir.
yes, tell me. Yes, please. What is your problem? Otherwise, I will show you one example. Yeah.
Hello.
Yes,
સર
I'm
આમાં આપણે ડેસિમલ કીધું એટલે આપણે આમાં બેઝ 10 રાખ્યો. દાખલા તરીકે ઓક્ટલ કીધું હોત તો 8 રાખવાનો થાત ને આને આ જ પ્રશ્ન.
That's right, absolutely right. જો octal કીધું હોત તો 8 રાખવાના થાત. But એની કન્વર્ટિંગ મેથડ અલગ છે. આ મેથડ નથી. This is only for binary to decimal.
ઓકે ઓકે ઓકે
Suppose that I am again taking
Okay, okay.
1, 1. This is very simple example. Triple 1. So below 1, I will write 2 raised to 0. Second digit 2 raised to 1. And third digit 2 raised to 2. So 2 raised to 0 will 2 raised to 0 means
1.
1. So 1 multiply with 1. That's why I'm writing 1 here. Then after 2 raised to 1. Tell me. 2 raised to 1. 2. So 2 multiply with 1. That means 2, right? Absolutely right. Then after 2 raised to 2. 2 raised to 2 means 4. 4. So 4 multiply with 1. That means right. So now do the sum. 4 plus 2. 2 plus 1. What is the answer? Yes, right.
7.
So 7 is the answer, but write down just base.
7 base 10.
Yes, correct. Now solve this sum. I am giving you extra sum so you can able to solve and practice. First write this example, multiplication algorithm, and just solve this one first. And after I will ask randomize to anyone that give me the answer of this system. First example, then after second one is something like 1, 1, 1, 1. Third example is something looking like 0, 1, 1.
Sir,
Yes, tell me.
everywhere we take the base 2, like
Yes. So whenever you see the system from binary to decimal, everywhere you need to take the base 2. Why? Because binary number system base is 2. That's why. So you just need to increase the power from right to left, starting from 2 raised to 0 and goes up to the last digit. Now total 4 numericals are given in the binary. I'm not writing 2, but just consider the binary system because there are only 1 and 0. You need to convert into decimal. First answer will be by Yogita. Second answer will get from the Harsh Karya. Third answer will go from the Rahul Vora. And fourth will be Arzo.
सिर्फ मेरा खुदा जानते हैं मैं
So everyone is getting, anyone have an issue in the conversion from binary to decimal? Very simple. Just write the binary number. Below the binary number, just increase the power series, base of 2, 2 raised to 0, up to the last digit. Suppose that my last digit is 5th, then 2 raised to 4. Then after, multiply each. 1 with power system, 0 with power system. Then after, sum of the total numbers. Suppose that here 128, 32, 8, 4 and 1. So total sum is 173. And below the part, radix part, write down the base. Okay, can anyone tell me what is the answer for the first question? 101010. 1010. Speak out.
20.
20. First.
40 base
42
10.
base
40.
40.
The first one, that is 42. If your answer is different, then let me know. If you can't able to solve, I will solve it if you have any issue, because this is the really basic topic. If you are not understanding right now, it will be very difficult in the other upcoming sessions. Write down base here 42, base 10. because our result will be in decimal. That's why. So first answer is 42. Just confirm here your answer is right or wrong. First question, first sum, that is 42. Now can anyone tell me what is the answer of second sum?
31 base 10.
31 base 10.
31. Okay, 31 base 10. Right. So all of you are getting 31. If you have any issue, just let me know. Okay, in second answer, we are getting 31. Don't hesitate to ask me if you are not getting the answer. Otherwise, it will become very difficult afterwards. Now third,
27.
27 base 10.
Base 10.
Base 10.
27,
27.
right? 27 and base 10. Correct answer?
10.
10, right? So if you are not getting 27, just let me know. I am here to help you. Very simple. Just write up the 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 4, 5. Then after multiply each, because this is the multiplication algorithm, and make the total sum. Now last fourth, Arzu.
1.
1 base 10.
1 base 10.
1 base 10.
We are getting 1.
base to 10.
Yes, 1 base 10. Correct answer. So all of you are getting these answers. First answer is 42 base 10. Second answer 31 base 10. Third answer 27 base 10. And fourth answer 1 base 10. Everyone clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Perfect. Solve third. Okay. I am going to help you to solve third answers. So just let me write this.
Hello, sir.
Yeah, tell me. Yeah, please.
સર આમાં મોટા દાખલા તરીકે બહુ લાંબુ આપ્યું હોય તો કઈ રીતે કરવાનું આ જ રીતે આકલ વગેરે
આ જ રીતના કરવાનું. આખું પાવર સિરીઝ
દાખલા
ઇન્ક્રીઝ
તરીકે 8 9 આંકડા આપી દીધા
હા તો પાવર સિરીઝ આગળ આગળ જતી જવાની. જેમ કે અહીંયા પાવર સિરીઝ 2:7 છે, એનાથી આગળ વધતું જવાનું. 2:8, 2:9, 2:7, 2:11 જ્યાં સુધી પૂરી ન થાય ને ત્યાં સુધી. ભલે ને 100 બાઇનરી નંબર આપેલા હોય ટોટલ ડિજિટ, તો 2:99 સુધી આપણે જવાનું. બટ એવડું નહીં પૂછે.
ઓકે
એક થર્ડ તમને સોલ્વ કરાવી દઉં, જેમાં આઈ થિંક હતું. નાઉ ક્લિયર? કેન આઈ એબલ ટુ ક્લિયર ઓલ ધીસ? આઈ વોન્ટ ટુ erase. All of you done? Just write down the number 1, 2, 3, 4. Write down the binary numbers so I can clear this, because someone have an issue with the third number. Okay, so it's something looking like this one number. Sorry. What is the third number? 011?
011011.
Okay, fine. So I will start with the 2:0 here. Then after 2:1, 2:2, and after 2:3, 2:4, and 2:5. Now 2:0 means 1. So 1 multiply with the 1 means 1. Then after 2:1, that means 2. 2 multiply with 1, that means 2. Now third digit is a 0 because 2:4 will become 4. But 4 multiply 0 means totally 0. Then after 2:3, 2:3 means, can anyone tell me? 2:3, Barko.
8.
8
8. Yes, right. 8 multiply with 1, that means 8. Then after 2:4, 16. 16 multiply with 1,
16.
means 16. And last one is 0. Why? Because 2:15 will become 32. But 32 multiply with 0, it will become 0. So just make the sum 0 plus 16. 16 plus 8.
27.
8 plus 0. 0 plus 2, and 2 plus 1. That is 16 plus 8 means
27.
24. 24 plus 2, 26. And 26 plus 1 means 27. 27 is your answer. And base?
10.
Oh,
Nine.
now fine. Now clear everyone.
Yes, sir.
Okay, so only one.
Yes, sir. Yes, sir.
Yes,
Yes, sir.
Yes,
Clear.
sir.
Yes, sir.
Great, so nice of you.
Clear, sir.
Okay. Now, can you able to solve this a bit different number? 1, 0, 1, point. Point is here. 1, 0, 1. Now solve this and give me answer. But must be remember there is a 1 point.
Sir, 1.1.
101. Point 101. Both side 101, but between that there is a 1 point. XOF point XOF.
40.5.
40.5 आएगा
40.5.
40.
40.5.
40.5 base 10.
Base 10.
base 10 base 10
40.5 base
40,
10.
40,
40.5 base 10.
Okay.
40.
40.5, right?
5.5 base 10.
Someone is getting 5.5 base 10. Another answer
5.625 base 10.
5.625. Again, new answer. Anyone?
5.625 with base 10.
5.625 base 10. Now any more? Otherwise I will solve. Okay, so let me help you. So whenever you are getting the point, just make the division, like draw the some line. So in the left sector, right hand side, and there is a left hand side. In the left hand side, starting from 2 raised to 0. So 2 raised to 0 is here. Then after 2 raised to 1. Then after 2 raised to 2. Right? Up to this part, you people are clear. In the right hand side, again start from 2 raised to 0. But it will go in the negative system. 2 raised to minus 1. 2 raised to minus 2. Okay. Now again solve the left hand side. 2 raised to 0 means, can anyone tell me 2 raised to 0?
1.
Okay, so I am writing 1 here. 2 raised to 1 means 2, but 2 raised to 1 become 2. 2 multiply with 0 will become 0. That's why I am writing 0. Then after 2 raised to 2.
4.
4 multiply
4.
with 4. So we are getting in the left hand side 4, 0 and 1. Now
4,
right
0,
hand
1.
side. Right hand side 2 raised to 0.
1.
1. 1 multiply with 1 means
1. 2.
okay.
1.
1. Now 2 raised to minus 1. That is 0.5, right?
0.5.
0.5 multiply with 0 means
0.
0.
right. 2 raised to minus 2 means 0.25. 1 divided by 4.
0.25.
Rating 0.25. Now make the total sum. 4 plus 0, 0 plus 1, 1 plus 1, 1 plus 0, 0 plus 0.25. Now give me the answer. 4 plus 1,
5.25.
5. 5 plus 1, 6. 6 plus 0.5.
6.25. Base 10.
6.25.
So 6.25 will become your exact answer. Now you people are getting what am I doing here? Whenever you are getting the point, so just divide the portion. One portion is left hand side, another portion is the right hand side. In the left hand side, series is starting from 2 raised to 0 and goes to the positive side. 2 raised to 1, 2 raised to 2, 2 raised to 3, 4, 5, up to the last digit. While in the right hand side, series goes to the negative side, 2 raised to 0, 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, 2 raised to minus 4, minus 5, goes to the last digit. Now just do the multiplication. So I am writing 4, 0 and 1. Same multiplication do in the negative side, it means right hand side. So we are getting 1, 0.25. Now make the total sum. 4 plus 1, 5, 5 plus 1, 6, 6 plus 25, that means 6.25. Now you people are clear how to do the point sum, point binary to the decimal. Can you able to solve any example? Okay,
Yes,
I'm
sir.
writing one example here. 1101.0111. Solve this. So 1101 point is here 0111. Give me the answer. Just divide the portion. First 4 digit took as a left hand side, remaining 4 as the right hand side. Left hand side will goes in the positive power series and right hand side will goes in the negative power series. Yeah, someone said me 13.875. Another answer
13.875 best 10.
13.875.
Inchoter.
Okay, 13.875 means 13.875, right?
Yes, yes.
ચાલો બીજા કોઈને
13.87.
Yeah, 13.875. Another from girls side.
13 point.
Yes, any girls want to try?
13.875.
Yes, 13.875, correct. Base 10,
13.875.
correct.
Sir,
13.875.
Okay.
sir, can you explain one again?
Yes, so definitely I will calculate this sum. Don't worry.
Thanks, sir.
Okay, so now let me calculate. Now we are making the division from the point side. So in the left hand side, it is the positive series. So I will write 2 raised to 0, then after 2 raised to 1, then after 2 raised to 2, then after 2 raised to 3. In the right hand side, series will go with the negative number. So 2 raised to 0, then after 2 raised to minus 1, then after 2 raised to minus 2, and 2 raised to minus 3. Now left hand side, 2 raised to 1 means, can anyone tell me? 2 raised to 0 means
1.
1. So 1 multiply with 1. That means, then after 2 raised to 1 means 2. But 2 is multiplying with 0. That means I am writing 0 here.
0.
Right. 2 raised to 2 means 4. 4 multiply with 1 means 4. So I am writing 4 here. Then after 2 raised to 3 means
6.
2 raised to 3, beta.
8.
8.
8.
8 is multiplying
8
with
into 1,
1. Right. Now right hand side, 2 raised to 0 means 1. But 1 is multiplying with 0. That means 0 here.
0.
Right. 2 raised to minus 1 means 1 by 2.
0.5.
0.5. So I am writing 0.5 here. Now 2 raised to minus 2 means 1 divided by 4.
0.25.
0.25, correct?
0.20.
Correct.
0.25.
Okay. Then after 2 raised to minus 3 means 1 divided by 8. 1 divided by 8.
0.125.
0.125. 0.125.
5.
Now make the total sum. 8 plus 4,
12.
12. 12 plus 1,
12.
13.
13.
13.
I add kar diyo. 0.5 plus 0.25 plus 0.125. So it will become the 0.875. So final answer is 13.875.
13.875.
Yes. So point na jyare sum karo tyare be very careful. First answer is 0.5. Second answer is something 25. And third answer is something 125.
25.
digit આવે એવું જોજો બરોબર છે. So total will answer 5 to 5, 5 plus 2 7, and 5 plus 2 7 plus 1, so 13.875. Now clear everyone?
Yes, sir.
Okay,
Clear.
clear.
Yes, sir. Clear.
Yes, sir.
So I think we are lagging with the time because I also need to conduct your attendance. So next thing will not be completed within 10 minutes, but I will just give you the overview. Binary to these are the examples. Suppose that if you want to practice, then convert this number. Just
Sir,
tell me.
સર આપણે જે લાસ્ટ કર્યું ને પોઈન્ટ વાળું
Right.
એમાં જે ફ્રેક્શનલ પાર્ટ હોય
Mm-hmm.
તો જેમ કે આપણે વિધાઉટ જે ફ્રેક્શનલ આગળ વાળું હતું તો એમાં 2:0 થી સ્ટાર્ટ કરીએ વન્સ ને
Mm-hmm.
તો સર ફ્રેક્શનલ માં બી 2:0 થી જ ચાલુ થશે.
હા, both side 2:0. Suppose it fractional છે બરોબર, point વાળા digits છે એમાં left hand side પણ 2:0 થી start and goes to the positive series 2:1 2:2. right hand side જે હતું એમાં નેગેટિવ પાર્ટ બાજુ આપણે આગળ વધવાનું છે, starting from 2:0 જ, but 2:-1 2:-2 up to the last digit.
ઓકે.
Now these are the example. If you want to calculate, then you can do the calculation in homework. Just write down the number. Very easy task. Yeah, next conversion will take place from decimal to binary. No, first we'll convert every number.
પાછળ કરો ને.
Okay.
થઈ ગયું સર.
Okay. So next will be from binary to octal. So in the binary to octal, very easy. Just I'm getting the overview. In the next lecture, we will solve the many sums. So suppose that this is your binary number 1011001101. So you just need to group the number of 3. ત્રણ ના group બનાવવાના. Suppose that starting from the right hand side, that is 101. Again make the 3 digits group 011. Again 3 group 110. Again 3 group, but only 2 digits are here. So just put the 0 ahead here. So it will become 0110. Then after you just need to convert into octal number. So 101 is something looking like 5. So in the next lecture, I will tell you why it's 5. Then after it's looking like 3. Then after it's looking like 6. It's looking like 1. So in the next lecture, we'll solve this sum binary to octal as well as binary to hexadecimal. So up to that part, everyone is clear. Are you people are getting my point? What am I actually trying to say that? Okay, if anyone want to give the feedback, so I can enhance my teaching scheme. So if you are not understanding or if you have any issue, કોઈ બોલી શકે છે, કાંઈ બોલવું હોય સારું હોય તો સારું કયો. but not in chat. Okay. All is okay. Fine. Okay, so it's really interesting. Suppose that if your math is really good, then definitely math will help you because it's looking like addition, subtraction, multiplication, and will entertain the division as well. So maths ની જેટલી સ્કિલ સારી હશે એટલી જ અહીંયા તમને ફાયદો મળશે. બીજું કાંઈ નથી, એકદમ સિમ્પલ છે. બચ્ચો કા ખેલ. Clear, fine. So let me see the attendance part. Yeah, I think series is starting from 9 to 3 times 0, 1, 0, 3, 0, 87. So I will just tell you only last two digits, 87. Don't write in chat box, just speak out if you are present, yes or no, absent or present, something like that. 87. 87 is not there, maybe. 88.
Present, sir.
89.
Present, sir.
90.
Present, sir.
91.
Present, sir.
92. Third year, okay. Third is here. 93.
Present, sir.
Okay. 94.
Present, sir.
95.
Present, sir.
97.
Present, sir.
98.
Present, sir.
100.
Present, sir.
101.
Present, sir.
103.
Present, sir.
104.
Present, sir.
105. 105 is there. Okay. 107.
Present, sir.
108.
Present, sir.
109.
Yes, 109.
Okay. 111. 112.
Present, sir.
113.
Present, sir.
114.
Present, sir.
115.
Present, sir.
116.
116 present.
117.
Present, sir.
118.
118 present, sir.
119.
Present, sir.
120. Hek Patel. 124.
Yes, sir.
125.
Present, sir.
126.
Present, sir.
128. 129.
Present, sir.
130.
Present, sir.
131. 132.
Present, sir.
133.
Present, sir.
134.
Present, sir.
135.
Present, sir.
36. 136. Deepen. Absent. 138.
Present, sir.
Okay. 139.
Present, sir.
140.
Present, sir.
141.
Present, sir.
142. Parth Sabaya. Absent. 143.
Yes, sir.
144.
Yes, sir.
145.
Yes, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50,
Yes, sir.
51,
Present, sir.
52,
Present, sir.
50, sorry, 164,
Present, sir.
176, 177,
Present, sir.
177, Dhiren Kanabar. Okay, it's not here. 178,
Yes, sir.
179.
Yes, sir.
Only 3 students are absent. One is 136, name is Dipen Solanki. And after 142, Parth Sabaya. And 177, Dhiren Kanabar. So thank you for attending and have a great day. You can leave the session.
Sir, Dhiren Karaban is present.
Number 177. So 142 and 136. So if your attendance is came, then you can leave the session.
हेलो सर
Yeah, tell me.
સર મેં ઓનલાઈન બી ચેક કર્યો એકવાર ખાલી જોઈ લેજો ને ફ્રેક્શન વાળું એ -1 થી સ્ટાર્ટ થાય છે
Okay, I will check it.
હે ને
Yeah, sure.
બીકોઝ મેં હમણાં જ ચેક કરી
Okay,
Thank
okay,
you.
I will check it. We'll solve in next session then.
ઓકે ઓકે નો પ્રોબ્લેમ